we are moving into the examples of the prolongs rule. Actually, the prolongs rule is the extension of the Cram's rule. And here we are inducing an chiral center to a carbonyl group which is attached to the ester group. So, and this carbonyl group is far away from the chiral center. Now, the substituent of the chiral center is represented by small, medium, large as we discussed in the Cram's rule. Now, the same nucleophilic addition occurs here, and the nucleophile is the R minus. And there are, as we discussed earlier, here also the carbonyl group is an sp2 hybridized and has a planar structure. So the the nucleophile have the two directions for the attack of the carbonyl group. One is in the upward direction and the other one is the downward direction. Then, as we discussed in the Cram's rule, the nucleophile attack towards the side of the smallest group. So the nucleophile attack in the carbonyl group in this side I have shown by the green arrow. Now, here we are inducing an extra chiral centers and we have to assign the one which is previously we have already a one chiral center in the starting material. We have to assign that chiral center as 1. Now we have generated an additional chiral center. The position of this additional chiral center is 4. So this type of the induction is known as 1,4 asymmetric induction. Since the chiral center which is already present in the starting material is assigned as 1 and the newly generated chiral center is in the 4th position. So in the Cram's rule and Felkinen model which explain the 1,2 asymmetric induction and the prolongs rule which explain the 1,4 asymmetric induction. And after the asymmetric induction we can remove the chiral center. So the prolongs rule is an example for the chiral axillary controlled asymmetric synthesis. In the last class, we discussed the chiral axillary asymmetric synthesis. The chiral axillary means it is an optically pure compound which is directly connected to the starting material. And this compound, the chiral axillary, will produce the hindrance towards the attack of the nucleophile to the carbonyl compound. And we can remove the chiral axillary after the asymmetric synthesis. And the chiral axillary can be regenerated, or it is a chiral axillary can be recycled, and so the final product which is produced is an enantiomeric compound. Thank you.